So last page of the 10.8 notes, we're still graphing polar coordinate systems. I want to talk about what it means to be a zero and what it means to be a max value. You guys are very used to your days in rectangular plane. I'm actually going to cover this. I'm not going to use it anyways. You're very used to thinking about a zero in the XY plane as being the values where you cross the axis. And that, in this chapter, will get you in trouble. In a polar graph, the zeros, so let's put that in here, a zero in polar is any angle. So a zero in polar is when my R value is equal to 0. So it's when I would plot at the pole. It does not necessarily correspond to where I'm hitting on the polar axis. So for example, if I flip over to, let's see, the first page is not a good example. If I flip over to, say, my second page, you might think that I have two zeros if you were using your knowledge from XY planes. But in fact, I do not have a single zero on this. There is no coordinate that goes through the pole. There's no coordinate on this function where R is equal to 0. So you want to remember that in polar, a 0 is when the R is 0. So essentially, you're going to solve for that. So in order to find the zeros, you would just let R be 0. So where does 0 equal 16 times the sine of 2 theta? Well, the 16 doesn't matter, right? We really want to know where sine of 2 theta is 0. And actually, I think we just solved this on the last page. Sine is 0. Oh, nope, we did ones on the last page. So sine is 0 when theta is normally 0 or pi or 2 pi or 3 pi and so on. And that would mean that my zeros are at 0 divided by 2, pi divided by 2, 2 pi divided by 2, or 3 pi divided by 2. And a lot of times they will tell you sort of how far to go. So if you look in our homework, sometimes they'll list and say, let theta be between 0 and pi, or theta be between 0 and 2 pi. Some of that just has to do with how long it takes for any particular shape to cycle through a full graph. But here we'll just say for the interval from 0 to 2 pi, and I'll include all of those choices. A max value, right? In rectangular coordinates, we might refer to something as like a max or a min. We talked about relative minimum values. Or maybe if I drew something like this, I could talk about a relative max. Again, that is in the XY coordinate system. We want to rip this up and get rid of it because just like with zeros, it's a completely different concept when I'm talking about the polar system. The maximum value of R is literally the max value of R. What is the furthest I will ever move away from the pole? So it is the largest possible R value. And we consider absolute value, so we don't want to consider -4 versus +4, something like that. And this would only happen, right, if you think about the sine function, its range of values is only between -1 and +1. So the only time that this could happen is when this will occur when the sine of theta is either plus or minus 1. Or if you're doing one, I keep pointing at sine here because it's a sine function, but when cosine is equal to plus or minus 1. You can use this to help you graph, or you could use a graph to help you figure out what the biggest R value is. It kind of goes back and forth. In this particular problem, right, if I wanted to think about the largest possible value, that would mean that R squared was going to be equal to 16. And let's see, if the sine was 1, we couldn't let it be -1 because R squared would never be negative. But if the sine value was equal to 1, then that would happen when R is 4. So where would that happen? That would mean that 16 times the sine of 2 theta is equal to 4. squared because it's an r squared formula. So I'm asking myself, well, where is the sine of 2 theta equal to 1? That will happen, right? 2 theta is equal to, the sine is equal to 1 at exactly pi over 2. Now, it doesn't have a minus 1 because of the squaring piece. So I would also want to include 5 pi over 2. And that would mean that when I divide by 2 to get my solution, I have pi over 4 or 5 pi over 4. So that value, the furthest away I will ever be from the pole, will occur at pi over 4 and 5 pi over 4. Now this particular form, r squared equals a squared. And then notice this time we have the sine of 2 theta. So different from the others, we have an r squared, not just an r. We have a squared. A is going to still be that distance, that furthest distance away, but we have sine versus cosine. So the other form for this is r squared equals a squared times the cosine of 2 theta. And this is what's called a lemniscate. Lemniscate. And a lemniscate looks like a figure 8. If you are dealing with a sine, your figure 8 will be sort of on the diagonal, and we'll graph that in just a second. If you are dealing with a cosine, your figure 8 would look more like an infinity symbol, and it would go in this direction. My drawings are a little messy, but you can also look on the pink sheet that I gave you, and you can see the forms for the lemniscates, and they outline the same thing. Your r value will be the distance from the pole to that outer edge, and we just determined that that distance is 4, and it's going in the direction of pi over 4, and it's also going in the direction of 5 pi over 4. If I know something about the shapes of these graphs, then rather than sitting and plugging in all those points, I can just draw my figure 8. It's going to look something like this, and really what it does is it wraps around and it comes back again. And I don't have to plug in all these other values. Now, if you forget what this looks like, then by all means, plug them in and you can figure out exactly the coordinates to graph. But a quick sketch is fine that says that you know sort of where you're at. So that was our last type, the lemniscate, and it also gave us a chance to talk about zeros and maximum R values. At the bottom, just notice our day 2 assignment, because this is the second day of notes. We're able to work through all the questions now. There's a couple of roses and a lemniscate, I think, at the end, and you can go back and answer all the questions. If you read the directions, it asks you for zeros and maximum R values for all the problems 1 through 14. So go back and make sure that you're all set on those. Thanks for watching.